Okay, today we're doing Module 5, Lesson 15, and as you can see, it has the exact same learning goal as yesterday. Just like yesterday, we're going to be taking what we've learned about area and using it to solve real-world problems. Today's problems will be similar to yesterday's real-world problems, but maybe a little bit more complicated and complex as this is the next lesson. Today, let's start by taking a look at our problem of the day, which is one example of a real-world problem involving area. Very good. This problem of the day is asking us to find out or figure out what the area of the flower bed will be. What important information? Take a minute, reread the question, and write step 2 in your notebook. All the important information you will need in order to solve this question.
Is 4 times as long as its width?
So the length is 4 times as long as its width. Anything else that we need to know?
Yes. And the width is 3/8.
The width is 3/8 of a meter. So we know that area is length times width. Do we know what the length is right now? No. But we do know that the width is 3/8 of a meter. So if this piece of tape, if this tape diagram represents the width, draw another tape diagram right underneath it that represents the length. Go ahead and do that. We know that the length is 4 times as long as the width. So is the length going to be bigger or smaller than the width?
Bigger.
Good. How many times bigger?
4 times.
So we have to take one of these, 2, 3, 4. So if one of these segments is 3/8 of a meter, how can I find out how long the width is? I can do 3/8 times 4, which is the same as 3/8 times 4 over 1. Do you agree? Are there any common factors that we might be able to use to simplify our work? Geffen?
4 and 8.
Are both divisible by?
4.
Good. What's 4 divided by 4?
1.
What's 8 divided by 4?
2.
So now this is the same as 3 over 2 times 1 over 1, which is 3 over 2, or 1.5 meters. So is that my final answer, 1.5 meters? Let me look back at what the question's asking. The question says, what is the area? Oh no, 1.5 meters is not the area. That's the length. So now if I know that the width is 3/8 of a meter and the length is 1.5 meters, how might I be able to find the area? So now to find the area, all I need to do is multiply the length, which is 1.5, times the width, which is 3/8. Do I need to make those denominators the same before I can multiply? No. Am I ready to multiply right now? In this case, I'm not ready to multiply because I have a mixed number. I have 2 choices. I could draw an area model, or I could make both of them improper fractions. Because 1.5 is quite small, I'm going to choose to use improper fractions. I know that 1/2 is 3 halves. 1 and 1/2, sorry, is 3 halves. I can multiply that by 3/8. Are there any common factors I could use to help me simplify my work? There are common factors. 2 and 8 are both divisible by 2, and 3 and 3 are both divisible by 3. Unfortunately, they're not in the right places for me to simplify. Do you agree? So let's multiply. What's 3 times 3? What's 2 times 8? So the answer is 9/16. That's half the answer. What should my units be? What should my units be? Square meters. Very good. In this picture, you'll notice that there are 4 different rectangles, yes? There's one that is very small. Okay. There's one that is a little bit larger. There's one that is just a little bit larger than that. And then there's one that is the largest. Do you guys see that? 4 different sized rectangles. The smallest rectangle measures 4.5 inches by 7 3/4 inches. So once again, the smallest rectangle measures how much? 4.5 by 7 3/4. My pen is not working. 3/4 inches. Okay? Then the question says, if 2 1/4 inches are added to each dimension as the rectangles get longer, what is the total area of the entire piece? So we know that originally the length was 4.5 inches, but the next time it gets a little bit bigger, how much bigger does it get? How much is it? It's 4.5 plus 2 1/4, right? Does that make sense? And then the length was 7 3/4 inches, But each time it gets bigger, it becomes 2 1/4 inches bigger. So what is my of my next biggest rectangle, what would the length be? Well, 4 1/2, instead of that, could we write 4 2/4? So what's 4 2/4 plus 2 1/4? 6 3/4. What's 7 3/4 plus 2 1/4? 9 4/4, or 10. So that means my next biggest rectangle, which in my picture over here is my blue one, the dimensions would be 6 3/4 inches by 10 inches. Then, to find my dimensions of my next biggest, which is my green rectangle, I have to take my old length, which is 6 3/4, and I have to add what?
2 1/4.
Good. Plus 2 1/4. To find my new width, I have to take my old width, which is 10, and I have to add 2 1/4. What's 6 3/4 plus 2 1/4? 8 4/4, which is? Okay. What's 10 plus 2 1/4?
12 1/4.
Good. And this is for what color rectangle?
Green.
Green. Very good. So go ahead on your third smallest or second biggest, whichever way you want to see it, rectangle, record those measurements. 9 inches by 12 1/4 inches. Because it tells us that each length or each dimension gets 2 1/4 inches bigger each time the rectangle gets larger, we can do our old length, which was 9, plus 2 1/4 to find that our new one is 11 1/4. And then our old one, which was 12 1/4, and add 2 1/4 to get 14 2/4, or 14 1/2. I always want to simplify it when I labeled my dimensions, because what am I going to have to do next? Find the area of each one. Is it easier to find the area when the numbers are bigger or smaller?
Smaller.
Very good. So go ahead and label that last rectangle. The dimensions are 11 1/4 inches. Now that we know the dimensions, the question is asking us, what is the total area of the entire piece? So now that we know the dimensions of the entire piece, how would we find the area of all of these rectangles? What would we need to do? Go ahead and talk at your table groups. Okay, we would have to find the areas of each rectangle using the area model, yes? And then once we found the area of each of the rectangles, we'd have to add them all up. Is that hard work to do?
No.
No. But think about how many steps there are. There's a lot, right? You know how to do this, but there's lots of opportunities to make silly mistakes. This is a great example of a problem you will see on your weekly check-ins and on your Module 5 tests, and possibly on your CASP test as well. You know how to do this, and I know you know how. I also know that lots of you will make silly mistakes. So try to organize your work and think about what you're doing. Don't skip steps. Does that make sense? Okay. For right now, we are going to divide up the work. Purple table, please find the area of the red rectangle. Blue table, find the area of the blue rectangle. Green, find the green. Yellow, find the yellow. Red, find the red again. And orange, decide for yourselves which rectangle you would like to find the area for. After we find all of the individual rectangles, we just add them up to see that the total area is 375 3/4 square inches. If we know that her basal plot is a 5/8 by 5/8 square, how could we find the area of the basal plot? What equation do we need to use? What equation could we do? Smart? What do you mean by? 5/8 multiplied by 5/8, or 5/8 times 5/8. Very good. What's 5 times 5?
25.
What's 8 times 8?
64.
So what is the area of her basal plot?
564
Square yards. Very good. That's part A, yes? Part B says, Mrs. Johnson wants to build a fence around her basil. If the fence is 2 feet from the edge of the garden on each side, what is the perimeter of the fence in feet? First, underline what the question is asking. From here to here. 5/8 of a yard. We know that from here to here is 2 feet, right? And from here to here is also 2 feet. So in order to find the perimeter, we have to figure out, well, what's the distance from here to here? So is it 2 plus 5/8 plus 2?
No, 5/8.
Is it 2 plus 5/8 plus 2? Go ahead and talk at your table groups. Why or why not? In order to find the length of the fence, we would have to do 2 feet, do you agree? Plus 5/8 of a yard, plus 2 feet. Do you agree? Is that the same thing as 2 plus, okay, let me switch to a pen tool. Is that the same thing as 2 plus 5/8 plus 2? No, because that is in what? Yards. And this is in what? Do we have like units? No, we have yards and feet. So what do we need to do? We need to convert this to, good. And we can do that by doing 5/8 of a yard is equal to 5/8 copies of how many yards? 1 yard. Very good. Which is equal to 5/8 times equals 5/8 copies of, now what do we want it to be in? Feet. So 1 yard is the same as how many feet? 3 feet. Right? So now we're ready to multiply. What's 5/8 times 3? 15/8, which is 1 and 7/8 feet. So how can I now find this length right here? I can do 2 plus 1 and 7/8 plus 2. Do you agree? 2 plus 1 and 7/8 plus 2, which is 5 and 7/8 feet. Is that my final answer? What is the question asking me to find? So if this from here to here is 5 and 7/8 feet, what is this over here from here to here? Yeah, good. And then what is this? Across the top? 5 and 7/8. And what is this? 5 and 7/8. So in order to find the perimeter, what do I need to do? 5 and 7/8 times? Very good. We know using the distributive property, we have to do 4 times 5, which is 20. And then 4 times 7/8, which is 3.5. So if I combine those, 20 plus 3.5, what do I get? Good. Is it in square feet or just regular feet? Because perimeter is just a distance. It's the distance around a figure. Okay, so the perimeter is 23.5 feet. Part C asks, what is the total area in square feet that the fence encloses? Well, in order to find the area, we have to multiply the length times the width, right? So what is the distance from here to here? How much? 5 and 7/8 what? Feet. What is the distance from here to here? 5 and 7/8 feet. Very good. How do you then find the area? Well, you just do 5 and 7/8 times 5 and 7/8. I suggest that you use an area model for this one. Do you agree? Very good.